Hello everyone, I hope that you all are doing great. This is the third video of the chemistry series on this YouTube channel. In the first two videos, we have covered a ton of topics, and today we are going to cover even more topics. In case you don't know, in the first video, we discussed about chemistry. It was an introductory video, and the second video was about atoms and atomic structure and elements. So if you have not watched these two videos, I will put the link on the I button so that you can go ahead, instantly watch those videos and then come back to this video. And with that said, I am going to introduce today's topic, that is going to be atomic bonding. Now, atomic bonding, there are three types of atomic bonding. They are ionic, covalent and metallic, and we are going to be discussing about all three of them in detail. And in case you again don't know, my name is Jindani and I will be teaching you chemistry throughout this YouTube series. So without wasting any more time, we are going to get straight into the video. Now, the first thing that you need to know before watching this video is the agenda, what we are going to cover today. So I have split this video or divided this video into 5 distinct parts, and each part we are going to discuss a lot of things. So the first thing is atomic bonding, which is basically the introduction to this topic, which is why do atoms bond, what is bonding, and generally about bonding. Then we have these three types of bonding, and in each type we are going to discuss about what that type is, how they are bonding, what is the procedure of that bonding, and we are going to discuss some properties of the compounds that are formed. And finally, we are going to have a conclusion that is, going to be about all three of them mixed together, right? So just a general, ending to the video. So these are the 5 separate parts, or you can call them chapters, as per the YouTube's, features. You can call them chapters, and they will be, with the video so that you can easily watch it. And now we are going to start. So first things first, atomic bonding. This is today's topic. This is the topic for the video, right? So we are going to first discuss what is bonding, because obviously without knowing what is bonding, we cannot, be able to know the types of bonding and other information associated with bonding. If you don't know about atoms, this is atomic. So if you don't know about atoms, you can watch the previous videos. We have covered a ton of information about atoms, and I'm not going to obviously repeat that. So basically, bonding is the lasting attraction between atoms, ions, or molecules that enables the formation of new compounds. So basically, in bonding, what we are doing, we are taking atoms, ions, or molecules. Now, if you don't know about them, I'm going to explain, that enables the formation of new compounds. So you are taking these things and you are making new compounds. You are reacting them, you are, whatever you do, you are making new compounds out of them. Now you guys know about atoms, and as we proceed with this video, we are going to discuss about ions and molecules as well, right? So don't worry about that. Now that we know what is bonding, let us see the types of bonding. So you can see that bonding is divided into 3 types. The first one is ionic, the second is covalent, and the third is metallic. And this is a very brief summary of each of these bondings. So in ionic, you are basically transferring electrons. In covalent, sharing electrons, and in metallic, freeing up electrons. So what do we mean by that? Basically, let me tell you about stability first. So these are the 3 types of bonding, and we are going to discuss about each of them in their own separate chapter, right? Now comes the concept of stability. So if you look at the noble gases are the group 0 of the periodic table, right? If you look at the noble gases, they have a very special arrangement of electrons. Yesterday, like in the last video, we discussed about the arrangement of electrons, also known as the electronic structure, right? So if you look at the electronic structure of the noble gases, they have 2 electrons in their first shell and if they have more than one shell, their outer shell consists of 8 electrons. So for example, let me give you an example of helium, right? Helium, we have 4 and we have 2, right? So if you were to make the electronic structure of it, you know that the period number is 1 and it would be 2. If you talk about neon, right? So neon has 10 electrons. So if you were to make the electronic structure, you would take 2 dashes and you would do 2.8, right? Which means 2 in the first shell and 8 in the last shell. Similarly, as we proceed, we observe a pattern that all the first shells contain 2 electrons and all the last shells contain 8 electrons. I'm going to give you another example of, let's say, argon, right? I'm going to give you an example of argon. Let me just make sure that I'm using the correct symbol. So AR and 18, right? So here you can see 18 electrons or 18 protons to be, So we have 3 blanks because the period number is 3 and you can see 2, 8, 8. So again, same kind of pattern, 2 in the first shell because, its capacity is 2 and 8 in the last shell. Why 8 in the last shell? Because 8 makes the stability, right? So that is what we are going to discuss in the concept of stability. So this kind of 8 electrons in the last shell and they are also called as valence electrons. Valence electrons, they are also called. So same thing, you can also call them electrons in the last shell, outer shell electrons, or you can call them valence electrons, right? So we call this a stable arrangement of electrons. Why? Because every shell has been satisfied by 2 or 8 electrons, right? So this is the reason why the noble gases are unreactive. They do not react with anything because they are already stable. They already have, the required electrons, right? So they don't have to react to be stable. They are already stable. Now, what is the point of discussing all of this? Basically, it is to tell you that the stability of an atom depends on the number of electrons in the outer shell, aka the valence electrons, right? So this is the main idea here, right? Now we are going to talk about why do atoms form bonds, because that is the very natural question that comes to our mind, that why is there a need to form bonds when you can, go without bonds, right? So atoms, why are they forming bonds? And atoms bond with each other in order to gain a stable arrangement of valence electrons similar to the noble gases, right? So as we discussed, that noble gases are already stable. They do not have to react, they do not have to form bonds. But the other elements, except for the noble gases, they have to form bonds, they have to react in order to get a stable arrangement. So it generally means that they try to gain 8 electrons in their valence shell or the last shell, or if it is helium, which is the noble gas with one shell, it requires only 2 electrons in the last shell, right? So it is kind of like this, right? And if you don't know about the noble gases, let me tell you, noble gases are these. So these you can see, this is the group 0, or some people also call it the group 8 of the periodic table, where you will find the noble gases. So these are the noble gases, and they have they usually have, this has 2 electrons and the others have 8 electrons in their outer shell, right? So that is what we have discussed so far, right? Now let me give you an example. So if we talk about hydrogen, right? Hydrogen has 1 proton number, which means it has 1 electron, right? And if you look at the period, there is the first period. And if you don't know what we are doing with these blanks and all, it is covered in the last video. Once again, you should go ahead and watch it. And so hydrogen has one, and basically its electronic configuration is 1, right? If you want to make this hydrogen stable, what will you have to do? You will have to somehow make this a 2, because we want 2 in the outermost shell. So this was the example of hydrogen. Again, we can talk about other examples as well. We can talk about, let's say, chlorine. So we are going to talk about chlorine now. Chlorine, okay. Chlorine has 17 electrons or 17 protons again, and it has a period number of 3, right? Which means it is located in the third row of the periodic table. Now, if we look at this 17, we basically, when we figure out the electronic configuration, group 7, so 7 over here, and then we can put the 2 and the 8. So you can see that chlorine has 2, 8, 7, and if you know about stable arrangement, we need an 8 over here. So what do we do to get an 8? We basically, you can just somehow, like, obviously we are going to discuss, but just giving you an idea, we are somehow going to bring this to 2, 8 and 8. Now, another example, just to make things clear, I am going to talk about another example. So let's talk about sodium. Sodium symbol is Na, and we have 11 proton number or 11 atomic number, which is the number of electrons. We take 3 electronic shells. Why? Because the period number is 3, and we make the electronic configuration group 1 and then 2 and 8, right? So this is the structure of sodium. Now if we want to make it stable, now what you need to understand here is, if you want to make this sodium stable, what you are going to basically do, you are going to do 2.8. So what did we do here? We basically removed 1 electron from sodium. So this is a concept that you will get familiar as we proceed along this video. As we learn more and more things, you are going to get more and more comfortable with this thing. This is basically why we are doing that, because obviously gaining 7 electrons is not an easy task. Chlorine, in the case of chlorine, it had to gain only 1 electron, which is possible, right? But gaining 7 electrons from another element, it is almost impossible, and it is better to, it requires a lot of energy, so it is better to give away this electron, and just one shell automatically disappears, right? It just, you don't have to mention it, because obviously 0 electrons, that means that shell doesn't exist. You should know that the shells are imaginary, right? They are not like really present, they are just imaginary shells, the orbits, right? So this is how you do it for sodium. And with that said, we have completed the first thing that we had to do, and that was atomic bonding. This was an introduction, and I hope that it is, by now it is clear. Now we are going to move to this new topic, that is ionic bonding. This is one type of bonding. Again, I am repeating, this is one type of bonding, others are covalent and metallic. Now we are going to discuss ionic bonding. So first we have to discuss what is an ion, right? Because if you don't know what is an ion, how are you going to talk about ionic bonding? So an ion is basically a charged particle. All right, charged particle, it can have a positive charge, it can have a negative charge, but it is not neutral, right? Here I've written it is not neutral. So the charges are formed due to an unequal number of protons and electrons, right? Pretty understandable, right? Because if you have equal number, then it is not charged, right? In order to carry a charge, you have to have unequal number of protons and electrons. Now it is the same as an atom, except that it is not neutral in nature. What do we mean by that? So we discussed about atoms. In the previous video, we discussed about atoms, that they are the smallest of all particles that cannot be further broken down by any chemical means, right? Same goes for ions. Ions are also atoms. They are pretty much atoms, but we don't call them atoms because they carry a charge. Atoms do not carry a charge, right? So that is the basic thing that you need to know. So for example, we can have a sodium, as we discussed earlier. We can let me bring it a little down. So we can have a sodium that carries a positive charge. Why a positive charge? Because look, we used to have 11 protons, right, which are the positive charges. Actually, let me, yeah, 11 protons and 11 electrons, and the charges would cancel out, right? But when we removed one electron, as we discussed above, you can just go ahead and look at this, right? When we removed this electron, what happens? Well, we get 10 electrons, which is why we are left with a positive charge, because obviously, if you remove electrons, you are going to get more protons, which means more positive charges. So the sodium that we discussed earlier is positively charged, and these positive ions are called cations. So this sodium ion, it is known to be a cation. Now again, in the case of chlorine, we lost one electron, so we can use Cl1 minus. Again, you don't have to write this one, it is up to you. You can just go like this. Same goes for sodium. So negative ions are called the anions. So this is a very small concept that you need to know about cations and anions. I wanted to include this in the video so that if you hear the words cation or anion, you don't get confused. They are just simply ions with a positive or negative charge. So I hope so far so clear, right? And now we are going to discuss about an ionic bond. So what is an ionic bond now? Because we've already discussed about ions, now we have to just put everything together to know about the bond. So the ionic bond is the bond that forms between the ions of opposite charge. Okay, so the ions that are oppositely charged, which means cations and anions, right? The ions attract each other. The ions attract each other due to the strong electrostatic forces between them. So the electrostatic forces, if you don't know, they are the charges, ठीक है ना? They are the electrostatic forces are basically, electro means charging, and the static means they are stationary, right? They are not moving. So these are the electrostatic forces that are between them. Now this is called the ionic bond. So we are going to discuss the examples, and hopefully that should make ionic bonding very clear for you. So the first example that we are going to discuss will be about sodium chloride. So we have a sodium, we have a chloride ion. We already know that sodium is positively charged, chloride ion is negatively charged. And yeah, I just made this L capital. I'm going to make it a small one because obviously the symbols are these. So we already know about the charges, and it's now time to draw a diagram. So I'm going to make a circle right now, and another one for chlorine. And basically what we are going to do, we are going to discuss how this ionic bonding works. So this is sodium, this is chloride, again this is chloride. So now what we are going to do, we are going to draw the electrons. So sodium, for sodium, let me just change the color. Yeah, so for sodium, we are going to draw this dot kind of electron, and for chloride, we are going to draw crosses, right? So 1, 2, 3, 4. I'm just drawing it in pairs of 2 so that it is easier for you to see. right? Now, what we are talking about in ionic bonding, we are discussing that this sodium has a valence electron. It has a single valence electron, while chlorine has 7 valence electrons. So what do we do here? We basically transfer this electron to chlorine, and that is how they both become stable. So this electron goes to this position, and that is how ionic bonding works. So this, if we let me just copy paste this thing. So if I, oh my, if I were to duplicate this and explain to you, or maybe I won't duplicate because we're out of space. So this is before the bonding. After the bonding has taken place, what do we get? We get, first of all, let's remove this arrow. So so after the bonding is complete, what do we get? We get this electron over here, and remember we take the last shell electrons. So now sodium has how many electrons in the last shell? It has 8 electrons in its outermost shell. We are not, it looks like we are, gaining electrons, but we are losing electrons. That is why we eliminate that last shell, and now we have a new last shell, right? So before the ionic bonding, we had 2.8.1, that is the electronic structure. And after the bonding, we are now left with 2 and a 8. Similarly, for chlorine, we had 2, 8, and 7. Now we have 2, 8, and 8. That is how the simplest of ionic bonding works, by the transfer of one electron from an element to another. That is it. That is how it works. Now we are going to do another example of calcium oxide. So let me show you the periodic table. So calcium is in the second group. Here you can see calcium. And chloride, once again, we're talking about oxide. So oxide is in group 6, right? Group 2, group 6. I told you that these are 1, 2, and then 3, 4, 5, 6, 7, and 8 or 0, right? So we have calcium in group 2, we have chloride oxide in group 6. This is in period 2, this is in period 4. So yeah, we have got all the information that we need, and now we are going to work with this example. So let's do this. We are going to do this. So first things first, we are going to make simple data. So we have a calcium that belongs to period number 4 and group number 2. For oxide or oxygen, we have period number 2, group number 6, right? So now let us make that similar diagram. So we are going to make 2 circles once again, and let me draw this again. So we are going to make 2 of these again, and this time we have calcium. We've got calcium and we have got oxygen. So in this example, we are having 1, 2 electrons in the outermost shell, as you can see by the group number, right? Let me just write it down here. So 2, we have period of 4, which means we have 4 electronic shells, and we have a group number of 2, and calcium has a proton number of, I believe, 20, while oxygen is let us just confirm right now. So we are really zoomed up. So we have a 20 and an 8, right? Again, you need all of the information just to do the correct working. So we have a 20 here, we have a 8 over here, and now we know that this has an electronic structure. So let me write down the electronic structure. We have 4 shells. In the last shell, we know there are 2. right? And in the other shells, we can, you know, work this out. As I told you in the previous video, we can work this out as 2882. And for for oxygen, we have 8. So 8 is like, you can see 6 in the outermost shell and 2 in the first shell. So we are going to draw these as well, cross diagrams. So again, these are 6. So you might have guessed, once again, these two electrons, they are going to go to the oxygen. So one is going to come over here, the other is going to come over here. And after the bonding has taken place, we are going to have this kind of structure, right? And we are going to have these two more over here. Right, and one thing that you can do after the bonding has taken place, you can also show that these are ions by, you know, drawing these kind of square brackets and writing down the charge. Now this has lost 2 electrons, so it is now positively charged, right? So it has 2 more positive charges than the negative charges, and this has gained 2 electrons. So we can write 2 plus 2 minus. In the previous example, once again, we can write Na plus and Cl minus. You can again write 1 plus, but it just works like this as well. So now we are left with this kind of structure. So we have 2, 8 and 8, and we have 2, 8. So hopefully this example once again makes everything clear, but in order to proceed, we have to do a final example. And this is the last one. So yeah, I know you must be tired, but you know, you should make all the concepts clear. So this is the third example that we are going to do, and this is about magnesium chloride. So let us make the electronic structure, but before that we are going to once again visit the periodic table just to get some information. Where are we? So we have magnesium over here in the second group and third period, and chloride once again we have in the second kind of sorry, in the seventh group, and the period number is same, that is 3. So let us go back, and yeah, and also the proton number or electron number is 12 and 17. So again we have got all the data, right? Now that we you know, we are going to do magnesium 12, chlorine 17. We have got the period number, which is 3, and the group number is 2. The group number is 2. We have got the period number 3, and we have got the group number as 7. Now here is the tricky part, right? So if I make one magnesium and one chlorine, right? I make one magnesium and one chlorine. We have Mg, we have Cl. Now what happens here? You have 2 electrons. You have got 2 electrons in the magnesium's outer shell. Why? Because the group number is 2, and 7 in chlorine. So we're gonna make 7. 1, 2, 3, 4, 5, 6, and 7. Now the problem is this guy has 2 valency, while chlorine can only accept 1, right? So what do we do in this case? Well, in order for things to work out, what we need is 2 chlorines, right? Because if there are 2 chlorines, each of them can accept 1 electron from magnesium. So what I'm going to do here, I'm just going to make another chlorine out of it. So now we have got 2 chlorines and 1 magnesium, right? And now this electron can go here, and this electron can go here, right? So you can see that this is how we work out, the imbalances. So magnesium can give away two electrons, but chlorine can accept only one. So this is kind of an imbalance. So if you encounter kind of these things, you can always increase the number of atoms that you are taking, or the ions to be, so number of ions that you're making. So in this case you can see that the magnesium, and now again we are going to work out this thing. So before the transfer we had 2 8 and 2. For chlorine we had 2 8 and 7, 2 8 and 7. After the transfer has taken place, this guy gets a charge of 2 positive, and these chlorines or these chlorides, if you have ions, you have negative ions, you might want to end them with ide, because it is a sign that these ions are negative. So I'm going to call them chloride, right, rather than chlorine. So the chloride ions and the magnesium ion. Now we have, after the transfer, we've got 288 and 288, and you can see that all of the atoms or all of these ions are all three of these are now stable, right? All three of these are now stable, and you can see after the transfer has taken place, this will be here, this will be here, and 1 2, after that 3 4 5 6 and 7 8 in the last shell. So that is how it all works out. And this was a lot of things for ionic bonding. But ionic bonding is kind of lengthy. That is why, I'm going much slower with this topic. It is lengthy, and it is, the most lengthy and a little bit tough than the other ones, probably. So now we want to discuss about the key properties of ionic compounds. So the first property is melting and boiling points are very, very high. Second property, usually soluble in water. And the third property is conduct electricity when molten or dissolved. But before that, one thing that I forgot to show you, this. So this is an ionic compound, right? You can see this is the compound NaCl, right? After the compound is formed, we write it like this. This is called the formula of the compound. So in this example, NaCl, in this example, we have got Ca, let me change the color, CaO, right? And in this example, we have got Mg, or let's write it on the top. We've got MgCl2. Why 2? Because we are taking 2 chloride ions, right? So this is NaCl, sodium chloride, and this is called a lattice. This is called an ionic salt, right? What is formed after the ionic bonding, whatever is formed, we call it a salt. Now you might be thinking, well, we have salt in our homes, right? So what about that? So yeah, NaCl is the salt that we normally consume, that we are having in our homes. That is mostly NaCl, sodium chloride. But there are other salts as well. You can talk about magnesium oxide, you can talk about calcium oxide, you can talk about magnesium chloride. There are many, right? So these salts form a lattice kind of structure, right? LATTICE, right? Maybe, I don't know. Yeah, so this kind of structure is formed, and that is probably it. Nothing more to discuss. Maybe yeah, we are left with the properties. So this is called a lattice structure, and this is the structure of a salt. Now coming back to the topic, and yeah, one more thing. Here you can see these are Na ions. So this ion, many more. Okay, and the green ones are the Cl ions. So these, they are structured in a way, they are structured in a way that the attraction between them is a lot, and that is why they are pretty much unbreakable. So we are going to discuss about the properties now. This I have told you because without that, properties would be a little bit more difficult to discuss. So first things first, they have high melting and boiling points. I'm first going to erase this thing. Just make some space. Right now, first thing, that is high melting and boiling points. You should know that ionic compounds, they have very high melting and boiling points, which is why they are solid at room temperature. The salt that you eat, other ionic compounds, they are solids at room temperature, because the forces of attraction between them are very, very strong. We talked about the electrostatic forces, the forces of the charges that are stationary, right? The electrostatic forces, which are very strong, due to which they have high melting and boiling points. Second thing, they are usually soluble in water. How are they soluble in water? Well, if you don't know, first let me tell you, water itself is made up of ions. You might know about the formula of water, that is H2O, in which two kinds of ions are present, the H ion and the OH ion. Now you might be thinking, well, how is this OH? It's not in the periodic table. So this is a compound ion. We are going to discuss about that later. But if you know, just for your knowledge, water has these H ions and these OH ions all along. Okay, so H might be here, OH might be here, right? There are many OH might be here as well. So water is made up of these ions, right? They are spread around. Now if you put some ionic salt inside of water, say you put NaCl inside of this water, which is like this. So if you put NaCl inside this water, what is going to happen is that the Na ions and the Cl ions will separate. Now remember that we had a lattice kind of structure that I showed you earlier on, and now that structure is broken down into separate ions. So that is what happens when you put ionic salts in water and stir them. That the ions that they are composed of, they break apart because of the forces inside of water. So that is how this thing works, right? Now we are done with the, oh yeah, the third key property that I'm going to discuss is that they conduct electricity. So let me clear this up right now, and I'm going to talk about the third property. Now, whenever they are molten or dissolved, so I told you about the dissolved one, they have ions. So they have Na plus ions, Cl minus ions, along with the water ions, which are H plus and OH minus. Now these ions can carry electrical charges as well. So if you pass electricity through this setup, it is going to easily be able to conduct it pretty well. But if you take this in molten state, so you again melt the NaCl, same thing happens, right? Na gets separate, Cl gets separate, but they are in liquid form as opposed to the aqueous form. But still, if you pass electricity through them, it is going to be able to pass, right? That is why that is the basic thing, that they conduct electricity in both forms. But in solid form, they cannot conduct electricity because the ions cannot carry the charges as they are fixed, right? Electrical charges cannot pass through. So these two states, molten and dissolved, which are also called liquid state or aqueous state, these are the states in which they can conduct electricity. And the final topic of ionic compounds is compound ions. Now that was a very kind of funny thing, but yeah. So we have a compound ion. What is a compound ion? It is a group of bonded atoms that have a charge on them. So this, you know, you've learned about compounds, you've learned about NaCl, you've learned about other compounds as well. Compound ions are kind of like them, but they are also same as ions, except with the exception that they contain more than one atom. So they contain more than one atoms. Now there are many compound ions, you know, but the most common ones that we, you know, usually talk about are ammonium hydroxide, nitrate, sulfate, and carbonate. So let me just give you an example of ammonium. Ammonium has the formula NH4, right? And what happened? Yeah, ammonium has a formula of NH4 and it has a positive charge, right? Now let us talk about hydroxide. Hydroxide has the formula OH negative, the one we discussed above in water. It has a negative, you know, charge. And next is nitrate. Nitrate is NH3. And then we have the sulfate. So sulfate is SO4. We have got the carbonate, which is CO3. And yeah, to put the charges, we have got 2 minus for this, 2 minus for this, and a negative charge on the nitrate. So these are the compound ions, and they are also used to form the compounds, right? So you might have ammonium chloride, which would be NH4. What happened to my writing? Ammonium chloride, which would be NH4Cl. You might have this water out of it. You might have the nitric acid, which is NH3. You might have, you know, barium carbonate, I don't know, BaCO3. So you can have ionic compounds like this as well. And these are the two ions in it. So this is a 2 plus ion, this is a 2 minus ion. So, you know, you basically get the idea that compound ions work like this. So these are the 5 basic ones. Again, there are more, but we need not discuss them right now. Now we are finally done with ionic bonding and we are going to move towards covalent bonding. So this is another, you know, vast topic in its own, but we are going to cover it briefly, you know, trying to not go too much into depth, but at the same time, you know, providing you with as much information as you need. So yeah, covalent bonding. What is covalent bonding? So if we look at it, the covalent bond, covalent bond is formed when atoms share electrons. In this type of bonding, atoms combine to form molecules. Now, what is a molecule, you might ask? Well, here is the answer to your question. So, what is a covalent bond? First of all, a covalent bond is made when two atoms are sharing electrons together, right? Sharing is caring, and they are making molecules. What is a molecule then? So, what is a molecule? A molecule contains more than one atoms. It contains more than one atoms, and it is basically a group of atoms that are held together by covalent bonds, right? So a molecule is basically you have 2, you have 3, you have 4 atoms combined together. That is called a molecule, and they are, you know, held with the covalent bonds. Now, this is a very rough idea. We are going to discuss more about covalent bonds. So first of all, what are the types of covalent bonds? Now, yeah, let us discuss first the types of covalent bonds. So any covalent bond can be single, double, or triple, depending on the atoms that, you know, we are taking, that we are using. In a single bond, you can have atoms share 2 electrons, which with each atom providing a single electron. So let me give you an example. for example, we are combining two chlorines together, right? We take these two chlorines and let me draw a circle around these. So this one and this one. Now we are actually, yeah, I should not be doing like this. So let me draw it once again. We have this chlorine and we have got this chlorine, right? Now what happens here, these two are the chlorine atoms. What happens here is this has 7 electrons, as we have discussed already, right, in its outermost shell. So chlorine has 7 electrons, 1 2 3 4 5 6 7, and similarly this chlorine also has I'm not going to draw the 7th one yet. This also has, let me draw it with a dot. So this has another 7 electrons, but I'm going to draw 6. Why? Because 2 electrons are being shared by these. Now what exactly do we mean by sharing? So while sharing electrons, both chlorines have a partial kind of charge, right? And partially they are stable, partially they are unstable, right? So for instance, if we just ignore this chlorine on the right side, right, if we just let it go, let me just do this, right? So think of it like this isn't here. Now what happens is these electrons, how many are they? 8, and these are orbiting this chlorine, right? But at the same time, if we think like this does not exist over here, then these 8 electrons are orbiting this chlorine. But what's cool about it is it is happening at the same time. So this electron will go orbit this chlorine, and then it will go orbit this chlorine, and it is in a loop kind of thing. So it will be orbiting both the chlorines and both will be satisfied. So it is like sharing, right? We call this sharing. So this is the single bond. Why do we call it a single bond? Because both of the chlorines are providing a single kind of electron in the center, in the sharing part. So now let us talk about some other covalent bonds. So we have got a double bond, we've got a triple bond as well. Let me clear this, and actually, yeah, we can use these circles already. Let me make these a little bit bigger. Right? So now let us talk about another one of these. So let us talk about oxygen. You have heard about oxygen gas. Well, it is this kind of structure, right? So what happens here, again, similar to that chlorine, what we are having 6 electrons in the outer shells, right? So 1 2 3 and 4. Again, I'm drawing 4. Why? Because, well, you will come to know. This is the 5 6 of this guy, this is the 5th and 6th of this guy. So now what is happening over here? You can see that again, if you ignore this part, you can see we have 1 2 3 4 5 6 7 8 electrons, right? And if same thing, if we ignore this part, we have 8 electrons, which means these 4 electrons are actually orbiting this as well as this, right? So that is how the double bond works. And similarly, if we were to take nitrogen, for example, which belongs in the in the 5th group of the periodic table, which means it has it requires 3 more electrons, then, well, you guessed it, you will have it kind of like this, and you will have one more removed, or maybe not. So it has 5, and yeah, probably like this. So we have 1 2 3 4 5 6 7 8. No, so we need one more also, right? So this is kind of a triple bond. Now again, you can see that basically both of the nitrogens, if you ignore one of them, you ignore this guy, well, you can see 3 and 3 6 and 2 8. Similarly, if you look at that nitrogen, you have 8. So this is how the covalent bonding works. I know it might be confusing, but again, it is not that confusing, right? You can just grasp these topics, you can rewatch this, explanation, and you will get the hang of it, right? So this was, these were the three types of covalent bonds. Again, there are more examples of covalent bonding which I'm going to share with you. So we just discussed about oxygen, which is the formula for oxygen is O2, and the bonding, as I showed you, you can also draw these simpler diagrams like or no, I'm going to draw that same diagram. So it is kind of like sharing 1 2 3 and 4 electrons with each other. So other examples of these covalent bonds, we have got methane, which is the uh, uh, what do we call it, which is the compound that is present in your natural gas that we use in our homes. So this is methane. This is again a molecular compound, and you can look at the structure like this. So we have a carbon in the center, and we have 4 hydrogens around it, right? This hydrogen, and this hydrogen, and each of them are sharing 1 electron. So this is like that one. So basically this is a single bond, and what we are getting, we are also having these 4 more in carbon, 1 2 3 4, and we are having 1 more in hydrogen as well. Or no, we don't have 1 in hydrogen because hydrogen already has 1, and it gives away that electron in sharing. So you can see hydrogen, all the hydrogens are having 2 electrons, while the carbon, if you count the electrons of the carbon, basically or actually it doesn't have like this. So yeah, what is happening? Yeah, so hydrogens, all of the hydrogens, if you see, they are having exactly 2 electrons, while all of the carbons are having there is only 1 carbon, and it is having 8 electrons in total. So that is how it gets stable. Again, it is a very advanced topic. I'm going to give you more examples. We have got ammonia. We've got ammonia, that is NH3. We have also got carbon dioxide as a molecular compound, CO2. We have got water, one of the, actually, yeah, water as well, one of the compounds. And you can pretty much see that this is how it works. Now that we have done all of this, let us go and learn about these molecular substances. So we have these molecular substances, also known as the covalent structures. And basically, we also call them the weak structures. Why do we call them weak? Because the covalent bonds inside them are strong, but the intermolecular forces are weak, which means that they have a low melting point, they have a low boiling point, and yeah, that is the simple molecular structures, and then they are insoluble and do not conduct electricity. So let me tell you about each of these. So first of all, we have low melting and boiling points, right? So molecular structures, they have low intermolecular forces. Why do we have low intermolecular forces? Because the forces of attraction, they are not that very great in order to provide, because obviously if you heat that element, it gains energy, and it breaks apart because it does not have strong enough forces. This is why the melting and boiling points are low. Insoluble in water. Why are they insoluble in water? Because they cannot be dissolved in water, right? They do dissolve in some other solvents, but not in water. So an example of other solvent would be tetrachloromethane, which is the name of a solvent in which you can dissolve these, but again you don't have to go too deep into that, right? And then they do not conduct electricity because they do not have free ions, they do not have free electrons that can move around the structure, which is why they cannot conduct electricity, right? So hopefully that makes it clear for the molecular structures. And finally, we have got giant covalent structures. So the covalent bonds inside simple molecule inside the giant. So it is a typing like this. Actually, this shouldn't be over here. So now we are going to talk about the giant covalent structures. So when we talk about giant covalent structures, they are a bit different than the molecular structures. Why? Because they are, they are giant, they are vast, and they contain loads and loads of, atoms that are combined together. One example is diamond. Another example you have is graphite. So if we talk about diamond, let me show you a picture. So these are the structures of graphite and diamond, right? So you can see here that the graphite is arranged in kind of these layers, these kind of sheets on top of each other, right? And diamond is basically, all of the carbons, joined together. So both of these are made up of carbon. If you know, these atoms are all carbon atoms. Similarly in here, these are carbon. That is why we call them the allotropes of carbon. What is an allotrope? Allotrope is, it means that they are the two forms of the same element, that is carbon. Now, if we talk about the differences between the properties, well, diamond, as we all know, it is hard and it is solid, whereas graphite is soft and slippery. It is solid, but it is soft and it is slippery. Diamond does not conduct electricity. Graphite does conduct electricity because of that, layering and all. And both of them have a high melting point because they are giant structures. They are not molecular structures. They have very strong forces between them, which is why they have strong covalent bonds and the forces, which is why, they are having high melting points. Even though these forces are not that great, but again, the forces overall are pretty good. So that is it for covalent bonding. And now we are going to move on to the next topic, that is going to be metallic bonding. So let us talk about metallic bonding, right? First of all, what is a metallic bond? So a metallic bond is formed by the attraction between metal ions and the free electrons that are surrounding them. Now this is a little bit different as compared to ionic bonding and covalent bonding, because obviously you are not, transferring electrons, you're not sharing electrons, but rather you are freeing up the electrons. So what happens here? So let me draw this kind of thing for you. So we are going to draw the structure of maybe copper. So we have this copper, which has the symbol of Cu, right? So we have a lot of copper kind of atoms, and what we do here, we take these atoms and we kind of make ions out of them. So what are we doing? We are giving each of these a charge. You should know that copper can lose, copper can have 2 electrons in the outer shell. So all of them, they are having this 2 plus kind of charge. And then you might ask, well, where are the electrons going? Because obviously in order for it to have a charge, the 2 electrons should be going out of the copper. So what happens to the electrons? You get the electrons outside of here. So you get, for example, with this copper, you get 2 electrons outside. With this copper, once again, you get 2 electrons. Same for these 1, 2, 3, 4, 5, and you can say 6, right? So we get a total of 10 electrons and 5 coppers. So what is happening here, basically, these electrons are being freed up by the atoms, and the atom is becoming an ion, and these, because these electrons have a negative charge, right, and these have a positive charge, they are being attracted to each other, because you should know that the different charges always attract. So you can see that the atoms inside of a metal are tightly packed together in a regular lattice, which is this kind of structure, and it allows the valence electrons to separate from their atoms. So they are getting out of the atoms, but they still remain as a part of compound. And this is why these kind of metallic structures can conduct electricity, because these electrons can carry the electric charges that are coming, and electricity can pass through them, right, easily pass through them. So these are the key properties of metals. We already discussed them in the previous class, and I'm just going to give you a brief overview once again. Again, if you have not watched the previous video, you should. It's a good idea to go ahead watch it. And we have first shiny appearance, we have good conductors, they have high melting and boiling points because of this, kind of structure, right? They have a high density, they are malleable, they are ductile, they are sonorous. Again, we have already discussed this, so I'm not going to go too much into depth with it. But this is probably it, and we are done with today's lecture. Maybe. So we have covered everything that you need to know, almost everything that you need to know about atomic bonding, and I told you that we're going to have a conclusion. So yeah, we have finally covered all three types of bonding. We have covered ionic bonding, we have covered metallic bonding, we have covered covalent bonding, and also, we have covered these three bondings. We have covered an overview about bonding. Everything has been done. Now, one thing that I wanted to discuss with you is, how do we know what thing is, like, how do we know that which element is going to pick which kind of bonding? So for example, how do you know that always sodium chloride will be an ionic compound? Why can't it be a covalent compound? Well, you have some kind of basic things that I'm going to tell you. So the ionic bonding, if you talk about that, the ionic bonding, it usually, I'm again using the word usually because there are some exceptions to these rules, it usually occurs between metals and non-metals, right? Non-metals. The covalent bonding usually again occurs between non-metals, and the metallic bonding, as the name suggests, it occurs with the metals. So in metallic bonding we are having metals, right? So this is the very basic idea that you should have, that if you have, for example, a metal, we have discussed about metals in the previous class. So if you have a metal in the periodic table, it can form a bond with non-metal via an ionic bonding, right? So we have, so some examples, we can have magnesium as a metal, we can have oxygen as a non-metal. If we are having both non-metals, we can have hydrogen as a non-metal, we can have fluoride as a non-metal, we can have, oxygen as a non-metal, a lot of non-metals. And if you have metals, you can have copper, you can have again magnesium as well. Any metal can be present on its own, right? So that is a trick. Okay, you can call it a trick, you can call it a basic, kind of idea, that how to know which type of bond will be formed. And one thing more, hydrogen can act as a non-metal, it can also act as a metal, even though it is a non-metal, it has been classified as a non-metal, but it has, it can behave like a metal in certain circumstances as well, right? So that is probably it. And yeah, with that, the video finally comes to an end. We have discussed a ton of information about atomic bonding, and it's really been a very long video. And if you have watched it from the very beginning to the very end, well, hats off. And yeah, everything, I tried my best to fit in. And if there are still any concepts that are unclear, if you don't know anything, you don't understand anything, if I forgot to include something that you think might be useful, well, do let me know in the comment section below. And I have worked really hard for this video, so I would really appreciate if you would like this video and subscribe to the YouTube channel in order to support me in my mission of spreading education. And that's what I'm doing. And again, yeah, that is it. If you can, please make sure to share it with your friends and other students that are studying chemistry. And yeah, that is it. I'm going to end this video now, and I will see you in the next video, which is going to be about moles. Moles is, one of the very requested topics, and a lot of people, they think of it as a difficult topic. So I'm definitely going to try to simplify it for you in the next video, in the upcoming video. So stay tuned for that, and don't forget to subscribe. I will see you next time. Till then, take care and bye bye.